All right, I think it's time for a break on working with percent. So we're going to take a little algebra break and we're going to jump over into our next main topic, which is geometry basics. So we're going to be filling out some definitions on page 45 and 46. The definition pages is actually 45, 46, and 47, but we're going to do half of this today and do the other half another time. All right, so our first definition, this is something that indicates position. It has no size, but may be represented as a dot, and it's named by using a capital letter. So if you think about a dot and a capital letter, that will probably bring you to the idea of a point. Next, we have a one-dimensional figure that extends indefinitely far in two directions. So if you think about a figure like this is going to be a line. Now when we name lines, we generally use 2 points on the line. So I can call that line AB or line BA. And generally we write it like this. And that is line AB is the way that's read. The order doesn't matter. You can use BA as well. All right, next we have a flat surface that extends indefinitely far in all directions. This is going to be a plane. So if you look at your floor or your ceiling, imagine that that continued infinitely, and that would be considered a plane. So much of what we do, we're going to start is going to be two-dimensional geometry, which is geometry on a plane or a flat surface. Next we have a part of a line. It has two definite endpoints and is usually named for its endpoints. This is what we call a line segment. So for example, let's say this is our line segment with endpoint CD. We would write that as CD with a bar over it, and that is read line segment CD. You can also reverse the order and call it DC. Then we have a portion of a line with one endpoint that extends indefinitely far in the other direction. So imagine one endpoint and then it extends indefinitely in one direction. This is what we call a ray. Now to name a ray, we have to use the endpoint first and then another point on there. So I would call this ray AB. You always list the endpoint first. So that one you can't reverse. It does have to stay in that order, and you would read that ray AB. All right, now our next definition, this is formed by two distinct rays that have a common endpoint. So imagine I get an endpoint, and I put a ray going this way, and I keep the same endpoint and do a ray going this way. So we can see that what I've done is I've created an angle. Now there are a lot of ways to name an angle. One is to use this point right here, which is called the vertex. That's actually the next one, so let's go ahead and fill that in. So a vertex of an angle is the common endpoint shared by its two rays. So let me change colors here. That would be the vertex. Now if there's only one angle from that vertex, you can call this angle A. All right, so we use this little angle symbol. Another thing we can do, this is common if more than one angle uses the same vertex. We can use 3 points. You can call it angle BAC or CAB. So what you want to notice on that is the vertex has to be in the middle. Now just to make it more confusing, another thing we can do is put a number in there. So we could put a 2 in there, and then we could call it angle 2. So there are a lot of ways to name angles, and we'll see these as we go through some examples. All right, next we have a blank, have a common vertex and side. These are called adjacent angles. Adjacent is one of those weird words that's hard to spell. So let's try to draw out an example of this. We want a common vertex. So let's do an angle going, or a ray going this way and a ray going this way. And then put another ray kind of down the middle. All right, so if we call this angle 1 and this angle 2, we would say angle 1 and angle 2 are adjacent. The word adjacent means next to, but they do have to share both a vertex and a side. So common vertex and side. Blank of an angle is the number of degrees in the interior of the angle. This is just going to be the measure. And we're going to measure that with a protractor. We'll talk more about how to do that another day. All right, if we have two angles with the same measure, we don't use equal so much in geometry. We use the word congruent. So I'm going to say congruent angles. I'm going to abbreviate angles like this. And the symbol for congruent is an equal with a squiggly mark over it. And it basically means same size, same shape. So the idea behind the congruent sign is equal implies they're exactly the same thing. So since they are two distinct angles, we use congruent to indicate that they are the same size and the same shape, but they're still two different objects. All right, next we have an angle whose measure is 90 degrees. That's going to be a right angle. I think we're all familiar with what a right angle looks like. I will attempt to draw one. And to show a 90-degree angle, we usually use a box. So that box, when you see that, that means 90 degrees. All right, now our last one on this page, an angle whose measure is greater than 0 but less than 90. This one's called an acute angle. Okay, so for an example, I want to make sure that it is smaller than a 90-degree angle. So something like this. Sorry, I'm running out of room on the bottom of this page. All right, so let's look at the next page. We have an angle whose measure is greater than 90 but less than 180. And we would call this an obtuse angle. And if you want, you can abbreviate angle. So this one's going to be bigger than 90. You can usually spot them just by looking at them. All right, so that would be an example of an obtuse angle. And next we have an angle whose measure is 180. So remember, there's 180 degrees in a straight line. So we're going to call this a straight angle. Now we tend to think of a straight line as not being an angle, but imagine that there's your vertex and you flatten out your rays so that they make a straight line, then that would be 180 degrees. All right, next we're going to look at sets of two angles. So two angles whose measure sums to be 90. And then the next one is two angles whose measures sum to be 180. So let's try a picture first. So for the first one, I'm going to try to start with a 90-degree angle. And then I'm going to split it into two. So there's one and there's two. So I would say the measure, I'm going to use an M, the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So M means measure, and we use that when we're talking about degrees. So these types of angles are known as complementary. So be really careful how you spell this. So these are complementary angles. Notice that there is an E there, not an I. Okay, and then for angles that add up to 180, to draw those you can start with a straight line. Let me try that again. That was not very straight. All right, straight line. I'm going to cut that into two angles. So let's call that 3 and 4. And I can see if I put those angles together, their measure is going to make a straight line, so they're going to add up to 180. And we call these supplementary. So supplementary angles. And these only work with angle pairs. We're only looking at two angles at a time. All right, so next we have lines that are in the same plane. Okay, so imagine maybe two lines in your floor, maybe in your floorboards, or two lines in your ceiling. They would be in the same plane, and we call these coplanar lines. So co means together, planar means on a plane. All right, so imagine this is your plane. All right, you've got some flat surface here, and you've got a line here, and you've got a line here. Those would be considered coplanar. Now, if they're not on the same plane, I can't demonstrate this on a flat piece of paper, but if they're not in the same plane, they're called skew lines. So I'll give you more examples of skew lines when we can get back to some in-person. So these would just be lines, two lines that are not contained on the same flat surface. All right, next we have points on the same line. So imagine you have a line here, and all of these points are on that line. Let's call them A, B, and C. Those would be together on one line. So we're going to say they are collinear points, and that means together on a line. If I take points like this, let's call these D, E, and F, we can see that those are not contained on one line. So these would be non-collinear points. Okay, and that's because they can't find one line that will go through all three of them. All right, now let's think about two lines with exactly one point in common. If I draw two lines and they have exactly one point in common, I kind of missed the point, but that's okay. We would call those intersecting. So intersecting lines. Okay, next we have congruent angles that are formed when two lines intersect. Let me try this. Let's see if I can get a better, that makes my line straight. That's way better. All right, so let's do our intersecting lines here. We end up with four angles. I'm going to call them 1, 2, 3, and 4. And what you might notice is that angle 1 and angle 3 look like they're about the same size. And then 4 and 2 look like they're about the same size. So it turns out that when you do intersecting lines, these ones that are across from each other, they're always congruent. So angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. So you get these pairs of congruent angles, and they are known as vertical angles. Okay, so 1 and 3 are vertical angles, 2 and 4 are vertical angles. All right, our last two definitions. Lines that form right angles when they intersect. You know what, let me go back to my straight line tool here. All right, so if we take a look at that, we can see these are all 90-degree angles, and these are known as perpendicular. These are perpendicular lines. And let's call this, here's another way to name a line. I'm going to call it line 1 and line 2. If I want to state that they're perpendicular, I have a little bit of a shortcut. This looks like an upside down capital T, and that's read as perpendicular. So I would read that line 1 is perpendicular to line 2. Now the last one we have are coplanar lines that do not intersect. So coplanar means they're on the same flat surface, but they don't intersect. All right, so that would be a pretty decent example. And we call these parallel. So parallel lines are coplanar lines that do not intersect. So if I call this one line 3 and this one line 4, and I want to state that they are parallel, I just use what kind of looks like an 11. It's basically just two parallel lines, and that is read line 3 is parallel to line 4. All right, so that's just a little bit of basic geometry vocabulary, and we'll get